Hi, my name is Jorge Nuno Silva, and I would like to talk to you today about something related to the number pi. Of course, pi is a very old number. Everybody knows today that given a circle, the ratio between its circumference and its diameter is a constant. Well, that has not been known since always. However, today about pi we know a lot. Thousands and thousands of pages have been written about this fantastic number. The ancient Greeks, for instance, used polygons to get to an approximation of pi. Archimedes, for instance, got the well known 22 sevenths as the upper bound for the real value of pi that was used for many centuries. However, the ancient Egyptians knew nothing of this, and it is about ancient Egyptians that I want to talk about today. So we go to the Ring Mathematical Papyrus, a beautiful collection of problems that comes from this fantastic civilization. It's a very old document with lots of very uh, interesting surprises. They knew nothing about pi. Nothing. They didn't know that there was a number associated with circles that was a constant. Nothing of the sort. So how did they manage to calculate the area of a circle? Actually, they did just that. And in this papyrus, they took a circle of diameter 9 and found that an approximate value for its area is 64. Now, the ancient Egyptians did not have a way of describing with generality their methods. They could not use our modern x's and y's. So when they use an example, a numerical example, we should be very attentive to the numbers they choose. For instance, here the diameter is 9 and it's not a random number. You will see in the process, in the description I'll give, that this 9 makes sense because, in a way, 1/9 of the diameter is the relevant unit for our process. On the other hand, I call your attention for the fact that the area of a circle here is found to be a square number. 8 times 8, 8 square. So the area of a circle is found to be close to the area of a square, which is very easy to calculate. Now, the area of a diameter of a circle of diameter 9 is 63.617 and so on. So the value the Egyptians found, 64, is very good. And I'm going to try to describe the method because it's really interesting and elementary. So let's take a generic circle, diameter d and radius r, and apply what we think was the thought process of the scribe of this papyrus. First step, we consider the circumscribing square to the circle. So the diameter was d, so the side of this square is d. We divide each side in 9 equal segments, and here we understand why the diameter was chosen to be 9, because the relevant unit is 1/9 of the diameter. So the area of the square in square units is 9 times 9, easy to calculate. Now, consider this octagon. To form this octagon, you just take the middle thirds of the sides and connect them. This octagon is not regular, however, it has two nice characteristics. it somehow approaches well the circle, and on the other hand, its area, it's easy to calculate. And that's because when you look at the area of the square that the octagon misses in these four squares, in four corners, you see that it misses at each corner half of a 3 by 3 square. So the area missed at the corners is just 4 times 1 half of 3 by 3, which gives us 18 square units. So the area of the octagon is 81 minus 18. 81 is the whole square, 18 is the area missed, so we get 63 square units. And here the scribe has a fantastic procedure. He says that 63 is almost 64, and 64 is a square number. So it's actually the area of a square of side 8. So the area of the octagon is very close to that of a square of side 8. But on the other hand, the area of the octagon is also almost the area of the original circle. So he concludes that the area of the circle is approximately 8/9 of the diameter squared. And this is the Egyptian formula, so to say, to find the area of a circle. And it is remarkable if we now think a little bit anachronically and introduce our pi. We know that the exact formula for the area of the circle is pi r squared. If we compare this with the expression the ancient Egyptians got, we see that it corresponds to taking an approximation of pi given by 16 squared over 9 squared, which is 3.16 something. It's a very good approximation for pi, obtained by very elementary methods, way before the concept of pi appeared. Actually, this all happened a very long time ago. As a practical rule to find the area of a circle, well, given its diameter, just take 1/9 out of it, form the square, and you can see that the squaring, so to speak, is very, very close. And this was the ancient Egyptian method to calculate the area of a circle. Thank you very much.